What's up, my people? In this video, we're going to be talking about arithmetic and geometric sequences. And these aren't that difficult. If you don't know the notation, it'll look kind of crazy, but it really doesn't. It's really not that bad. So let's give you a quick rundown on what you're going to be looking at. So arithmetic, in this sense, we call it arithmetic instead of arithmetic. Because in this case, when it follows by the word sequences, it's called arithmetic. Arithmetic means we're adding or subtracting. Okay? When we get to geometric, that means we are multiplying or we're dividing. Okay? Now, we're gonna have two words that you're going to see. We're going to have two different types of formulas. The first type of formula is called recursive. And the other one is going to be called explicit. Okay? Recursive pretty much, recursive, what that means is what pattern did you notice? So when you write your recursive formula, are you telling me is what pattern did you notice? Okay. You need to be able to identify a pattern to get the explicit formula. The explicit formula is the formula to get any number in the list. So recursive says, what pattern did you notice? And explicit says, hey, I got the work. Just tell me what number you're trying to get to, and I'll help you get there. Okay? So, and we'll talk about those in a second. Now, you're going to run into some things that you're going to see. Actually, let's go ahead and talk about it now. So for your arithmetic formulas, we'll do this back in green. Your recursive formula is going to be a of n equals a of 1 plus d times n minus 1. And explicit is going to be a of n equals, oh, I'm sorry. This one up here. This is your explicit formula. So I wrote them backwards. Explicit. And this one down here is your recursive. JK, LOL. Okay, recursive says a of n minus 1 plus d. All right, so let me just help you let's just get through what some of this vocabulary is. All right, so anytime you see a of n, that's just pretty much telling us what number in line we are looking for. So, for example, if I had the numbers 2, 4, 6, 8, and 10. This 2 is first in line, so that will be a 1. This 4 will be second in line, so that will be a 2. This 10 is fifth in line, so that will be a 5. So when you have the A in that small number just says, hey, that's the number we're looking for. We use A of N when we don't know what number we're looking for yet until somebody tells us what number we're looking for. Okay? And just to finish this out, this will be A3. This will be A4, dot, 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 dot. And so we use these formulas because what if I want to know what A502 is? That means you would have to write this list out all and get every single number until you got to the 502nd number and tell me what that number is. That's going to take you all day. So we would use a formula, okay? So that's what A of N. And then what I briefly mentioned just a second ago, A of 1 is always whatever number's in front, or they'll tell you your A of 1 is. So in this case, A of 1 would be 2. Whatever number's in front, that's your A of 1. Now, D stands for common difference. D stands for common difference. In other words, what did you add or subtract to every number to get your next number? Okay, so right here, plus 2. Right here, plus 2. Right here, plus 2. So my common difference would be 2. Okay, so that's what common difference is. And then, oh, so yeah. So when we write our stuff out, you'll probably want to start your equation. You always want to say my A of 1 will be, say, 2. My common difference would be 2 in this case. Okay? And then you can fill your stuff out. Now, when you get to your when you get to the, now this phrase right here literally means the number before. And to help you make this make sense, in order to get 6, you added 2 to the number before. So this formula for right here would be, so A of N equals A of N minus 1 plus D. Or actually, I can change that D because we already solved it. So when you write this as your recursive formula, what you're telling me is, hey, Hamilton, I looked at my previous number, then I added 2 every time. I looked at the previous number, add 2, get 6. Look at the previous number, add 2, get 8. That's how you're recursive. So all your recursive formulas are going to look very similar to that. Okay? Now, and then for geometric, no, let's just do some arithmetic, and then we'll come back up here for geometric in a minute. Okay? So let's just kind of split this down. Hopefully I got some space for geometric. Let's do some arithmetic ones. All right, so we got to have, let's identify so it says first, we got to find your common difference, the term named in the problem, and we got to find the explicit formula and the recursive formula. Okay, so first things first, let's identify our A1. What is the very first number mentioned? 30. Okay, now my common difference. What am I going to do? What's happening to get to the very next number? And my common difference is a positive 10. Okay, so common difference. And now we have this information. We can write our recursive formula. So our recursive formula, I'm just going to put this recursive, says, what do we do to get the next number? Well, we took the previous number and we added 10. This is the recursive formula. Our explicit formula is, okay, our explicit formula, if you look back up here, A of N equals A of 1 plus D to the N minus 1. So let's go back down here. So Our explicit formula, what is our very first number? Because it's a of 1. Actually, I'll do it like this. A of 1 plus d parenthesis n minus 1. Let's fill this stuff out. A of 1 is 30 plus d, which is 10. And then we have n minus 1. So that's the explicit formula for now. But the last thing we have is we have our n. Our n is this number right here. N says, I want to know, let's do that different color. N is saying, if you keep this pattern up, what number will be the 40th number that you come across? Oh my Lord. So what that means I have to do is this. So that means I want to know what a of 40 is. 30 plus 10. And then where this n was right here, I got to put 40 here minus 1. This number, this n, and this n are the same. Let's go ahead and put that in decimals. We don't want to do all that work. 30 plus 10 parenthesis 40 minus 1, or you could have just put 39, 420. So if we keep this pattern up like that and got to the 40th number, your number is going to be 420. So a of 40 is 420. Let's do number 2. So let's identify our A1. A1, easy. First number, 26. What's happening from this number to that number to that number to that number? What is happening there? We are adding 100. So that means D equals 100. Okay. Now, what is our recursive formula? Well, recursive is simply telling me, Hamilton, this is what I did. I took the previous number and I just added 100 every time. That is your recursive formula. Okay. Now, the explicit formula, and we're going to go ahead and fill in all the numbers. Let's find out what they're trying to get us to figure out. N is going to be 24. N is going to be 24. Let's go back. If N equals 24, and our formula, I'm just jot it right here so that we can have it handy. A of N equals A of 1 plus D parenthesis N minus 1. I'm not sure how helpful that's going to be with this thing in the way. All right, so A of 24 is going to be equal to A of 1. What was our A of 1? Right here, 26. Plus, what was D? 100. What was N? 24 minus 1. Okay, and let's do this really quick so that everybody remembers. This A of 1 always goes in the front. D is always this number here. And this 24 is always this number here. And it'll tell you in your problem right there. Okay, now we can put that in decimals as is. 26 plus 100 parenthesis 24 minus 1, or you could just put 23. 2,326. Now, if for some odd reason you needed to count to the 24th place, when you get there, it'll be 2,326. Okay, next one. Let's look at the next one. Here we go. Now, this one right here, number 3, let's erase this 424 right now and get it out the way. Let's just put it over here. All right. From negative 15. So either way, here we go. I got to find my A of 1, D. Let's do our N right now, too. So A of 1, negative 15. D. What is happening to get from one number to the next number? What's happening to get from here to here to here to here? We're subtracting 200. And they want to know what number will be 31st. So our recursive formula, are you telling me it's Hamilton? All I did was look at the previous number and I subtracted 200 every time. That's the recursive formula. Explicit is going to be A of 1. Sorry, explicit is going to tell us which number exactly we're looking for. So we're trying to find A of 31, not 24. I'm tripping. A of 31. So my A of 1 is negative 15 plus D, which is, or actually be minus, because now D is negative, N minus 1. And remember our N was 31. Okay, A of 1, D, N. Let's go ahead and just put that in decimals as is. So we got negative 15 minus 200 times, and I'm just going to put 30 because 30 minus 1 is 30. And if I kept this same pattern up, when I get to the 31st number down here somewhere, I'll be negative 6,015. Okay? What I want you to do right now is pause the video, and I want you to attempt to do number 4 on your own. Ready? Go. Now that you've had the time to attempt to do it on your own, let's do, and this one I'm gonna go a little bit quicker because we've been working through some of these. So A of 1 equals 29. What am I doing to get from the first number to the next number? 29 to 34 to 39 to 44. That means D is going to be 5. And then the N that we're going to look for, it's going to be 38. Okay? So recursive formula, I'm not going to make you do it. Let's just find A of 38. So A of 38 is going to be equal to A of 1 plus 5, parenthesis, 31, 38 minus 1. And then if you go to decimals, 29 plus 5, parenthesis, 37. And the answer, if you keep the same pattern going up, the 30th number would be 214. Okay? All right. That's arithmetic. Geometric is similar. We're going to go through this a little bit quicker because we don't spend that much time in geometric. Geometric is just when you're multiplying, okay? So when you have geometric, instead of adding every time, you're going to multiply something every time. So instead of having the letter D, we have the letter R, which is your common ratio. So G is your common ratio. As a matter of fact, let's go up here on this page. And we're just going to do the explicit formula. No, we can do the, I'll just give you the recursive. So the recursive is A of N equals the previous number times whatever number we just saw. This is recursive. under the geometric side. Remember, this is geometric side over here. Let's label this geometric, because I don't think I did. Geometric. And then the explicit formula for geometric is going to be your A of 1. But this time you're going to multiply times your R, and then going to do it raised to the n minus 1. Geometric, geometric ends up being growth and decay, by the way. Okay, so we'll just do a couple of these. And they want to find the 8th term. All right, cool. So my A of 1 is 1. My common ratio. What is happening to get from this number to that number, that number to that number? Well, we're multiplying that by 6. So we're trying to find the 8th number. And we're not going to do recursive this time. We're going to do only explicit, save some time. So A of 8 is going to equal, so remember the formula was A of n equals A of 1 times R n minus 1. This is our fantastic formula right here. That's so kind of messy. All right, anyways. So A of 8, so our A of 1 is going to be 1. Parenthesis, what's our R? 6. And we're trying to find the 8th term. Or you could have just put 7 up there. And let's see what that turns out to be. 1, parenthesis, 6, close parenthesis, raised to the 7. At this rate, if you keep this, if you keep this pattern up, keep multiplying by 6, when you get to your 8th term, it's going to be 2, 7, 9, 9, 36. And if you feel like trying it, because you already have your 1, 2, 3, 4, just do it again. All right, next one. Let's just roll through this. A of 1 equals 1. How do I get from here to there, to there, to there? I'm multiplying, which means that's an R, times 5. And I'm trying to find the 8th number. So that's going to be A of 1. And then my R is 5. And we're trying to get to the 8th one, minus 1. So let's just do this from scratch. 1, parenthesis, 5, close parenthesis, raised to the 7. So the 8th number in this line will be 7,825. 78,125. Okay? Next one. And I'll just do one more of these because I don't feel like doing this last one. Let's not do that. Let's do number 8. 8's my favorite number. Okay? A of 1. And I'm also looking for the R. Then we're going to find the A of 8. So what's my A of 1 on this one? -4. What's happening every time? I'm multiplying all these by 3. Okay? Now, and my A of 8 is going to be A of 1, 3, and we're trying to get to the 8 minus 1, which is 7. So I'm going to do -4, parenthesis, 3, parenthesis, raised to the 7. So if I kept this rate, my 8th term would be -8,748. Okay, next thing we're going to do is I'm going to go ahead and show you 2 star questions that look similar to this. All right, so here we go. Okay, here we go. Let's look at these questions and see which one of these makes sense. Now, these two questions, this top one was on the 2017 test, and the bottom one was on the 2022 test. So let's see which one of these makes sense. All right. So I want you to tell me what you think this is. What do you think the answer to 22 is? And then, so I want you to pause it and tell me what you think the answer to 22 is. Let's see what you got. So, let's see some things. Okay, we see this A of 1 has to be 6. All of them have 6. That doesn't help. Okay, now, the next thing we're going to look at is right here. And it's saying that our formula, let's do that in a darker color. Our formula is going to be 4 times the previous number should give us the next number. 4 times the previous number should give us the next number. So let's look at these. 6 times 4. Is that 20? No. 6 times 4. No. 6 times 4. No. 6 times 4. Yes. And then 24 times 4 is 96. Times 4, 384. So the correct answer would be F. See, it's not that challenging. Okay, now let's look at this one. And this is the last one. Now I want you to pause this right now and tell me what you think the answer is. Okay, now that you've done it, hopefully use Desmos for this one. Hopefully you did, because what I'm going to do here is check this out. First things first, I'm going to put all of my formulas in Desmos. So the top line is -4 in. The next line says negative parenthesis 4 raised to the n. The next one says negative n squared. And the final one says -4 raised to the n. All right, so I have all of these, right? Now, remember that this is A1, A2, A3, A4, A5, A6. Pick, so now we gotta plug in a number for n, but we want to pick one of the ones that's right here. And I always choose one of the back numbers. I always choose one of these. I always choose either the 5th or the 6th number. So when I put n equals 5, we should get negative 1024 when we plugged in 5. Okay? Because when A is 5, I'm going to point this out one more time. When A is 5, your answer should be, so let's look over here. Oh, not the top one, not the second one. Oh my goodness, there's 2 of them. So we got to try another number. So let's try 6. When you plug in 6, you should get negative 4096. And which one has negative 4096? The answer is going to be B. So when A, so we don't need this anymore. When A is 6, the answer should be negative 4,096. And we looked at our answers over here. The only one was the second one, which was B. Okay? Hopefully this helped out. And if you have any more questions, see me in class. Y'all have a good one.